Okay, today we're going to be covering 5.3. So update your table of contents and add your title page. We're going to do this as one video again today. Alright, so the things that are highlighted in yellow you'll want to copy down. We're talking about going from standard form today into factored form. And we'll be reviewing the FOIL method and different factoring techniques. And then the last thing you need is a zero product property. Okay, so we kind of reviewed this in class. X squared plus 2x minus 24. We're going to set up our t-chart. And we need something to add to 2, but times to negative 24. So we think about all of our factors of 24. And we know that 4 and 6 are going to, will those two work? They will work if we make one of them negative. So we want to make 4 negative. So that negative 4 plus 6 makes 2. And so we factor this by saying x minus 4 and x plus 6. All right, just another example, but this one's different now because we have that 2 in front of y squared. And when we have that 2, it makes things a whole lot more difficult. So this is a process that we're going to use to solve it. We're going to take the 2 and multiply it by the 18. So we'll rewrite this as y squared minus 9y minus 36. Now I can factor it like I was doing before. Adds to negative 9 times to negative 36. So what will work for that? So some factors are 6 and 6, that won't work. 4 and 9, that won't work. But 3 and 12, those two are going to work. And we would need 12 to be negative, so it's 3 plus negative 12 to make negative 9. So it is y plus 3 and y minus 12. But because we have this 2 out in front, we can't just be done there. We multiplied it in, we now have to divide it back out. And so the way this works is if the fraction reduces, like the second one does, we'll just reduce it and leave it. If it doesn't, we're going to take the denominator and put it in front. So it would be 2y plus 3. But this one just stays as y minus 6. So that's our method of factoring if we have that coefficient in front of x squared. Okay, so let's try another one. So we start by taking the 3 times the 8, and we'll rewrite it as x squared plus 2x minus 24. Set up our t-chart. And negative 24 and 2. Well, that seems familiar. We just had that a little bit ago. Again, it's 4 and negative 6. X plus 4 and x minus 6. But we multiplied by 3, so we have to divide by 3. The first one does not reduce, so we say it's 3x plus 4. And the second one does reduce, so it's x minus 2. Okay, so now looking at this, we have an x cubed in this one. This is a little different. So an x cubed is probably an indication that we need to go back to one of our other factoring techniques. First of all, I think we need to find a greatest common factor. So what do all three terms have in common? They all have a y, and they all have a 3. So we're going to pull out a 3y. If I divide a 3y out of the first term, I get 3y squared. Out of the second term, I get a 2y. And out of the last term, I pulled out everything. But I need a 1 there to hold its place. Because otherwise, when I distribute it back in, if I were to work backwards, I would only have 2 terms. Okay, now I'm not done because inside the parentheses, it looks like I could factor that one a little bit. So we've got a number in front of y squared. So we have to multiply it over and write it as y squared minus 2y minus 3. Now we have to remember we've got this 3y out in front, but we'll just drop that back down later on. So we add to negative 2 times to negative 3. That would be 1 times 3, and the 3 needs to be negative. So y plus 1 and y minus 3. But now we have to go back and divide by that 3. This denominator comes up, and that will reduce to 1. So we've got y, oh, I did that wrong, 3y plus 1 and y minus 1. And we need to just bring this down in front as 3y, and that is factored form. Okay, this one. This is going to be a perfect squared, so it's going to look a little strange when we get to the answer. But for right now, we're just going to set it up. Add to 10 times 25. There's not a number in front of x squared, so that helps us out. And so when we do that, we think it's going to be 5 times 5. So 5 plus 5. It's x plus 5 and x plus 5. And now we could simplify that by saying it's actually x plus 5 squared. That would be a more efficient way of writing it. And that's it. Now we will need to be able to recognize this in a couple lessons to be able to go from this answer back up to this. But we'll work on that a little bit more later on. Okay, this one looks like we should not be able to factor it. But it actually does work. It's called our differences of squareds. And the rule is a squared minus b squared can be factored as a plus b, a minus b. Well, 16 is a squared number because it's 4 squared minus y squared. So you would write this as 4 plus y, 4 minus y. So even though it doesn't look like it should be able to factor, we have to be able to recognize this rule. Okay, now this one. I don't really see much other than a greatest common factor, and that would be a 3. So we've got 4b to the 8th minus 9c squared. But now when I rewrite it like that, I notice that everything in there is a squared number. 4 is a squared number. B to the 8th actually is squared. It's b to the 4th squared. 9 is a squared number, and c is being squared. So since I notice everything's being squared and it's subtraction, we can go to that rule that we were just using. So it's 2b4 plus 3c, 2b to the 4th minus 3c, and again I can't forget about that 3 out in front. So I bring that down. Now we are completely factored. Okay, then it comes to solving it. So you have to solve it, you have to factor it first. Set up our t-chart, 10 and 16. So that's going to be 2 times 8. X plus 2, x plus 8 equals 0. Now we've got two terms multiplied together to make 0. The only way to get 0 when you're multiplying is the first term has to be 0, or the second term has to be 0. So we'd solve this. Most of you can do this in your head, but this is the work. So our two answers are -2 and -8. So we could write it out as -2, -8. So now when do you have to actually make a list of numbers, or when does it say factored form? Like we did, let's go back a few examples, like this one. This one we just left in factored form, whereas the last problem that we just did, we actually had to come up with a list of numbers. The main difference that we're looking for is this problem says to solve, and it has an equal sign. If we're solving and we have an equal sign, we have to do that extra step beyond factoring. Okay, let's try a word problem. So we've got an arch in the shape of a parabola represented by an equation. How wide is the arch at ground level? So if we think about this, and if we were going to be graphing it, we would assume 1 is at 0, 0, and we need to find this other point. And so we can graph it. Well, actually, we don't really need to assume that it's at 0, 0. In this case, it may not even be. But we can find these 2 points and then find the distance between them. But we know that it's going to be on the x-axis, so we're going to replace this with 0. So 0 equals 9 minus x squared. Okay, I recognize that as a difference of squared because this is a squared number. So that means you can do the double parentheses. 3 plus x, 3 minus x equals 0. And so then we have to separate them. And so 3 plus x equals 0. Or, oh, I'm sorry, I wrote this one wrong. 3 minus x, it should be right there. Or 3 minus x equals 0. Not that it really makes much difference. Okay, I think you guys can do this in your head. This one has to be negative 3. And this one has to be positive 3. So yeah, I was incorrect in my statement here that it had to be on the y-axis. Actually, it's the y-axis falls right in the middle of it. This is at negative 3, and that's at 3. So what is the distance between them? Is 6. And I believe we're talking about in feet here. Yep, it says here measured in feet. So 6 feet is our answer. All right, last problem of the day. Now, it gives us a roots, and we have to find the equation in standard form. So this means it gave us the answers that we just did, and we've got to work backwards. So we know that x equals 3/2, and x equals negative 4. Okay, so then think backwards. X minus what makes 0? X minus what equals 0 here? So if we're thinking about working this backwards, this actually was solving for x. So 3/2 minus what makes 0? Well, that's 3/2. And this answer went here. So negative 4/2 minus, well, actually that would be plus 4 makes 0. So that's the equations that would have had to been to give us those answers. So now we go back and realize, well, these would have been in the parentheses. To make 0. Well, then we're continuing to work backwards, and we could see that we would have to FOIL this to be able to write it out. So first 2 is x squared. Outside is 4x. Inside, 3/2 x. Last 2, if you're not good with fractions, feel free to take out your calculator, is going to be 6. And so the equation in standard form is x squared, and then 4 minus 3/2 is 5/2. Okay, I was thinking that was a final step, but you can't really have fractions to be in standard form. So how do we get rid of that fraction? Divide both sides by 2. I'm sorry, not negative 2, just 2. And so if I multiply everything in there by 2, kind of like when we were doing the elimination method, you get 2x squared plus, now the fraction will just become 5, minus 12 equals 0 times 2, just 0. That is our answer in standard form. So it's taking everything we just did and working backwards. Last thing for the day is there's an extra credit opportunity. If you take out your homework, the page that you're going to do your homework assignment on right now, and when you put your name on the page, if you put a big box around your name, I'm going to give you an extra credit point on your homework assignment. So I'm giving you extra credit for the fact that you watched and listened to the video. So don't forget to put a box around your name on your homework assignment.